How is heat defined in thermodynamics? Imagine holding a hot cup of coffee on a chilly morning. You feel the warmth transfer from the cup to your hands. That feeling is a perfect example of how heat works in the world of thermodynamics. In this field, heat is described as the transfer of energy between a system and its surroundings because of a difference in temperature. It is not something stored inside the system but energy moving across the boundary. When two objects touch and have different temperatures, heat flows from the hotter to the cooler one until both reach the same temperature, a state called thermal equilibrium. At the microscopic level, heat is related to how particles move. When molecules vibrate, rotate, or move faster, they carry more kinetic energy. When heat is transferred into a system, it causes these particles to move more vigorously, which often raises the temperature. But sometimes, the energy goes into changing the state of matter, like melting ice or boiling water, without changing the temperature. The first law of thermodynamics, which is also called the law of conservation of energy, tells us that energy cannot be created or destroyed. Instead, it can only change form or move from one place to another. Heat plays a big role here because it is a way energy enters or leaves a system. When heat flows into a system, it can increase the internal energy, which is the total energy stored inside. Alternatively, the system can use that energy to do work, like turning a turbine or moving a piston. In thermodynamics, it is important to remember that heat is always energy in transfer, not energy stored inside a system. It flows naturally from higher to lower temperatures. The amount of heat transferred depends on how big the temperature difference is, the type of material, and how much of it there is. Heat transfer can cause a change in temperature or even a phase change, like from liquid to gas. We measure heat in units like joules or calories, which are units of energy. Temperature, on the other hand, measures the average kinetic energy of particles. So, while they are related, they are not the same thing. Understanding how heat moves helps explain everyday phenomena, like why a hot cup cools down or how engines convert heat into useful work. It also helps us design better heating and cooling systems, from refrigerators to power plants. To sum up, heat in thermodynamics is the energy transferred across the boundary of a system because of a temperature difference. It influences the system's internal energy and often causes temperature or phase changes. This concept is fundamental to understanding how energy flows in physical systems and is closely tied to the first law of thermodynamics.